Good day, students. My name is John Obodo. So we are going to be looking at the second aspect of vectors that we treated earlier. We talked about vectors in 2 dimensions in our previous class. But in this class, we are looking at vectors in 3 dimensions. Okay? We have discussed 2-dimensional vector where we talk about that is 2D vectors. 2D vectors where we talk about I and J component of a vector. If we are given a vector A as xi plus yj, that means the modulus of A is the square root of x squared plus y squared. Okay, and then we also said that I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. But however, I dot j is equal to 0, j dot k is equal to 0, I dot k is equal to 0. So these are the rules that we need to understand when we're dealing with vectors. So when we want to multiply 2 vectors with in 2 dimensions, when we are given vector A is 2i plus 3j, and vector B is 3i minus 4j. Then A dot B, which is the scalar product of vector A and B, is the same thing as 2i plus 3j dot 3i minus 4j. So when we do this multiplication, we have 2i, that is 2 multiply this is 6, and 2 multiply 4 is 0, because ij is 0 based on this rule. So 3 multiply 3 here is also 0, and 3 multiply 4 here will give us minus 12, because j dot j is 1. So therefore we have 6 minus 12. Final answer is minus 6. Okay, we also been able to establish the multiplication. We can also do addition of those vectors. Vector A plus vector B is equal to vector B plus vector A. Okay, that means they are commutative. Addition of vector is commutative. We talk about commutative, that means you can swap the commutative, can swap the position of the vector. So that is for, what's it called? Addition. So if you add this, we have 2i plus 3j plus 3i minus 4j is equal to 5i, then minus j. So that is addition. And if you add it in the reverse order, taking the b vector before the a, we still arrive at the same answer to that. So we also discuss what we call the scalar multiplication of 2 vectors. When we say scalar multiplication of 2 vectors. Scalar multiplication, we are given vector A multiply vector B is equal to vector modulus A dot vector modulus B, then dot cosine angle between the vectors. And when we look at the cosine angle, we are looking at 2 vectors. 2 vectors of this nature, A vector and B vector, at an angle theta between each other. That means to find their angle between them, angle between the vectors, we use the scalar multiplication concept between the vectors. We use the scalar multiplication. And that is, we have cos theta is equal to vector A multiply vector B divided by modulus or absolute value of A and the absolute value of B, vectors respectively. So we have this equation for finding the angle between 2 vectors. So if we are given 2 vectors again, vector A is equal to I plus 3j, and vector B is equal to 2I plus 4j, we can say find the angle. Find the angle between vectors A and B. vector A and B. So to find this, we apply this formula, and we say cos theta is equal to vector A, which is I plus 3j dot 2I plus 4j divided by modulus of this, which is 1 squared plus 3 squared, in brackets, square root 2 squared plus 4 squared. So when we simplify this further, we have multiplication of this will give us 2 plus this will give us 0, 0 plus 3 times 4 is 12, divided by square root of 1 plus 9 is 10, multiply 2 squared is 4, 4 squared is 16, so we have 4 plus that will give us 20. So we have 20, square root of 20. So 10 multiplied 20 is 200. So we have 14 divided by square root of 200. 14 divided by square root of 200 is cos theta. Okay, so when you use your calculator, you can get the answer, and your theta will be equal to cos inverse of the value obtained, 14 divided by root 200. You can simplify further and leave your answer in such form if possible. We have cos inverse 14 divided by square root of this, we have root 100 multiplied by 2. And root 100 multiplied by 2, we have cos inverse bracket 14 10 root 2. Okay? So 2 here 7, 2 here 5. So we have 5. So we have 7 divided by 5 root 2. So that will be your cos theta. So when we use the calculator, we can be able to get the final answer to that. So that is for 2D vectors. When we are looking at the 3D vector, we have 3D vectors. In 3D vector, we consider 3 dimensions of the vectors. And that is talking about the XYZ direction at mutually perpendicular directions to each other. So how do we do this? We need to consider a vector R such that we have this as vectors acting at 90 degrees to each other. 90 degrees to each other. So we have this as XYZ. So we can get the vector of this position, and maybe this is the R. So to get your R vector is given as xi plus yj plus zk. And this is the representation of the vector R. So the modulus of vector R is square root x squared plus y squared plus z squared. Okay? So this is what we are trying to explain in the diagram there, so that we'll be able to apply that in solving some problems. So we can find the distance between two vectors. That is talking about distance between two vectors. We can represent a vector in respect to the geometry, what we call the coordinate geometry of the vector. And that is, we'll look at that as we continue in the class. So looking at some examples that may be related to 3D vectors, we talk about a vector A given as 3i plus 2j minus k, and vector B as 5i plus 6j minus 4k. And you want to add the two vectors. A plus B vector will result to 3i plus 2j minus k added to 5i plus 6j minus 4k. So when we add the two vectors using corresponding parameters or components, so we have this will be added to this, okay, and this will be added to this, and this will be added to this. So when we do that, we have 3i added to 5i, we have 8i, and 2j added to 6j, we have 8j, and 4k, we have minus, so we have 5k. So this will give us the vector sum of A and B. And if we want to do a subtraction, A vector minus B vector, that is subtraction of 3D vectors, you do the same corresponding subtraction, taking note of the sign, the negative sign. So we have 3i plus 2j minus k, subtract 5i plus 6j minus 4k. So when we do the subtraction, we have 3i plus 2j minus k minus 5i minus 6j plus 4k. You know, this minus sign, we cancel out this and it turns to positive sign. So we do the same thing we did here. 3i minus this is minus 2i. 2j and 6j is equal to minus 4j. And k, this is minus, and 4k, negative k and plus 4k is plus 3k. So we have a negative or subtraction of two vectors in a very simple example, as we have seen there. So we can also look at the scalar multiplication of two vectors and also what we call the vector multiplication. But based on that, we consider how we can get what we call the unit vector and the component vector, or what we call the modulus of vector. To find the component, or what we call the unit vector of a 3D vector, we need to consider the values based on what is given. Then we are able to solve a related problem. We look at an example such as vector P is equal to 4i plus 4j minus 3k, and vector Q is equal to 2i minus 3j plus 6k. I want to look at the products of the two of them. Vector P dot vector Q is equal 4i plus 4j minus 3k dot, that is dot product, 2i minus 3j plus 6k. So when we do the multiplication, considering the rules, remember the rules of I dot I is equal to 1, j dot j is equal to 1, and k dot k is equal to 1. But I dot j is equal to 0, and I dot k is equal to 0, j dot k is equal to 0. So applying that rule here and see what the answer will result to. So we have 4 multiplied this is 8. 4 multiplied this is 0. So 4 multiply any corresponding one that is not in the same, they have different components, we have a different answer, or 0. So what you have, you just multiply the corresponding I and I, j to j, and k to k. So what we do there is we just say 4 multiply this 8, 4j multiply 3j is minus 12. You have minus 12. And 3k multiply 6k is minus 18. So minus 12 minus 18 is minus 30. So you have 8 minus 30. The final answer is minus 22. So that means the dot product of vector PQ with respect to the 3-dimensional vector given, when we do the multiplication, we are going to arrive at that. Okay, so that is for the dot product. So we can also find the angle between the vectors when we consider vector P dot vector Q is equal to modulus of vector P, okay, multiply vector Q and multiply cos theta. So we can find the angle between vector P and Q using this. So let's solve it and see what the answer will look like. So cos theta is P vector dot Q vector divided by vector P dot vector Q modulus. So we substitute. We already have the value of this as minus 22. So we solve the others and say we have square root of P. P we have 4 squared plus 4 squared plus minus 3 squared. And the other one is Q. That is square root 2 squared minus 3 squared plus 6 squared. So finally we have minus 22 divided by, we have 4 squared here, and that is the same thing as 16, 32, and 9. 16, 16, 32 plus 9 is 32 plus 9 is 41. So you have 41 dots, that is product. 2 squared is 4, 3 squared is 9, 4 added to 9 is 13, 16 squared is 36. So we have 36 and 13, and that will result to 49. So we have square root of 49. Okay, you can check it again. 2 squared is 4, 3 squared is 9, so we have 13, and 6 squared is 36. Add it, we have 49. So square root of 49 is 7. So you have minus 22 divided by square root of 41 multiplied by 7. So we can solve this and get the cosine. So this is what we call the cosine of that. And we can use the cosine and find the inverse cos function of the answer we get here. So get the answer from here. Using your calculator, you can get the answer for this. Okay? And if we have been able to establish the fact that the scalar product of two vectors is given as this, we can also find the vector product of two vectors. So to find the vector product, we consider, first of all, let's look at what we call the direction cosine of a particular vector. But before we look at the direction cosine, we look at the unit vector of a three-dimensional vector. What is the unit vector of a three-dimensional vector? Unit vector, how do you find the unit vector? To find the unit vector of a 3D vector, we consider a vector A. Vector A, the unit vector of A is given as this, equal to vector A divided by vector modulus of A. That means if you are given A is equal to 2i plus 3j plus 4k, and want to find unit vector of vector A. That means we have this, that is vector A divided by modulus of A. So that is equal to 2i plus 3j plus 4k divided by square root 2 squared plus 3 squared plus 4 squared. So that is equal to 2i plus 3j plus 4k divided by square root 4 plus 9 plus 16. 4 added to 9 is 13. 13 added to 16 is 9, 29. So we have 2i plus 3j plus 4k divided by root 29. Okay, so this will give us the unit vector of vector A. Unit vector of vector A. And if we have been able to find unit vector of vector A, can we also look at the direction cosine? What is the direction cosine of vector, of a given vector? To find the direction cosine of a given vector, we consider the diagram shown. Let us consider the vector R is OP, which makes an angle alpha, beta, and gamma with the coordinate axes, OX, OY, and OZ respectively. Then cos alpha, cos beta, and cos gamma are called the direction cosines of the vector. Okay? They are usually denoted by L, M, and N respectively. So we are given a vector R, and the vector is given, the modulus is given as this, and we want to find the direction cosine. To find the direction cosine, we consider the vector with respect to the individual property of the vector. Now let's look at this as the direction cosine of a vector. To get the direction cosine of a vector, direction cosine. Cosine. We want to look at how we can get the direction cosine. We are given a vector R. Vector R as I plus 3j minus 6k. I want to find the direction cosines. How do you find the direction cosines of the vector? So the direction cosine will now be, you need to look for the value of R, modulus value, and that is square root 1 squared plus 3 squared plus minus c squared. Okay, minus c squared. So we have 1 plus 9 plus 36. 1 plus 9 plus 36. 36 added to 1, we have 37. 37 added to 9, that will give us 6. We have 6, 46. So we have root 46. So since we have root 46, direction cosine in the direction of x. In the direction of x, we have cos alpha is equal to x over modulus of r. So the x value here is 1. So we have 1 divided by the modulus value, root 46. And if you want to find the angles, we can say that alpha is cosine inverse of 1 over root 46. You can use your calculator for that, and you get your answer. If you are going to look at the answer to that, we consider cos inverse. We look at cos inverse of that. So 1 divided by root 46. Root 46 is the same thing as this. Then we find the inverse cosine function of that. Inverse cosine function of that is equal to this, 81. So we have alpha equal to 81.52 degrees. So we can also find the value of gamma. Okay, we have alpha, beta, and gamma. For beta, we have cos beta is equal to directional cosine of that. We have y, all divided by this. So we have y. What is the y? Y is 3 here. 3 all divided by the same value we obtained here, root 46. So you can also do the estimation using your calculator. Cos inverse 3 divided by root 46. So we have the answer for that. For gamma, direction cosine in terms of the z direction. So we have cos gamma. Cos gamma is a cos gamma is equal to z, all divided by the r, modulus of r. So z is here is minus 6. We have minus 6 divided by square root of that. That will be root 46. So you can also use your calculator and solve that. That is for cos gamma. So our gamma here will be cos inverse in bracket minus 6 over root 46. So this is the concept of direction cosine. So we are going to be looking at the other aspect, which is what we call the vector multiplication of vectors, 3D vectors. Okay, as we enter into that, let's be able to establish the direction cosine and understand the properties of multiplication of vectors. So with that, we can move on and look at this exercise that is on the board and solve that. So we can look at vector multiplication of 2 vectors or 3 vectors or 3D vectors. Okay.